All right, ninth graders, we're going to talk about Newton's third law today, and these are conceptual questions numbers 1 through 6. So question number 1, when a hammer exerts a force on a nail, how does the amount of force of the hammer on the nail compare to that of the nail on the hammer? Remember that Newton's third law says that every action has an equal and opposite reaction. And if you watched my notes, I said think of it like a caveman. Think of the two objects, and then you would say, if hammer push on nail, then nail push on hammer. Okay, those forces are equal and opposite. However hard the hammer hits the nail, that's how hard the nail hits the hammer. So the forces are the same. Newton's third law, equal and opposite forces. All right, number 2. When you jump up, why doesn't the earth move downward? So what this is saying is that when you jump, you push down against the ground. And so you push on earth, earth push on you. Earth push on you means you go up. But why doesn't the earth move downward? And again, this has to do with cause and effect. The amount of force on the earth is equal to the amount of force on you. However, the earth has a giant mass with a minuscule acceleration, F equals ma. You have a minuscule mass compared to a much larger acceleration. The product of m times a has to equal m times a, but the numbers don't have to be the same. So because of Earth's large mass, the acceleration is very small. And that is c. The Earth's mass, therefore its inertia, is so big that any acceleration it would have from your push is for all practical purposes equal to 0. Again, people think, oh, well, I must not be pushing as hard on the Earth because it doesn't do anything. The force is the same, the effect is not. All right, let's move on to number 3. When a rifle is fired, how does the size of the force of the rifle on the bullet compare to the force of the bullet on the rifle? If rifle push on bullet, then bullet push on rifle. Action-reaction forces are equal and opposite. So the forces are the same size. Again, we just kind of want to drill that into you. All right, number 4, how do the accelerations of the rifle and the bullet compare? Now this is where the acceleration is the effect of those forces. You've got the rifle and you've got the bullet. The rifle has a big mass, the bullet has a small mass. Therefore, the rifle has to have a small acceleration while the bullet has a large acceleration. Again, F equals ma, F equals ma. Ma times, or m times a equals m times a. The forces are the same, but the way they are expressed are different. Okay, so that means that our answer here would be, because of its lower mass, the bullet will accelerate more, B. All right, moving on to number 5. If a bicycle and a massive truck have a head-on collision, upon which vehicle is the impact force greater? Okay, the impact force, again, is going to be the same. You have your truck and you have your bicycle. Okay, if truck push on bicycle, then bicycle push on truck. Forces are equal. So the answer is C. Again, Newton's third law says that the forces are equal and opposite. Again, the effect is going to be much different. The bicycle will slow down the truck a little bit. Big mass, small acceleration. Little mass, big acceleration. But the forces are the same. All right, and finally, number 6. Which vehicle undergoes the greater change in acceleration? Well, I just sort of explained that, didn't I? Because of the small mass of the bicycle, it has to have a larger acceleration for the same amount of force. All right, that's numbers 1 through 6.